present my research work on 5G electromagnetic spectrum regime and environmental health ecosystem sustainability. It's a presentation by myself. Then, this is my presentation layout. The title page, if you click on title page, you take it to title page. You can move down again. So this is the flow of my presentation: title page, introduction, methodology, research findings, conclusion, and question and answer section. I go to introduction. What is 5G electromagnetic spectrum implementation? The widespread adoption of 5G cellular networks has drawn public attention, with some citizens viewing the fifth generation of wireless networks 5G as a threat to public health, believing that electromagnetic field EMF exposure is greater than exposure from the current 4G networks. Observations on 5G makes it difficult for some countries to fully deploy 5G networks into wide-scale digital consumption. With 5G electromagnetic spectrum are the ranges of electromagnetic radioactive frequencies, wavelengths, and photon energies that a 5G base station can transmit. We move to the next slide, still on the introduction. The 5G electromagnetic spectrum includes electromagnetic waves with frequencies ranging from 1 Hz to more than 300 GHz, corresponding to the wavelength ranging from thousands of kilometers corresponding to wavelengths ranging from thousands of kilometers to the smallest fraction in the nearest radius. The digital society reliance on the 5G mobile broadband with extraordinary data rates will require more electromagnetic spectrum to be available in the nearest future. The novel technologies, in conjunction with the subsisting telecommunication infrastructures, will require frequencies for their continual operation. The current research investigated the existing mobile terrestrial radio frequency bands and has proposed the trend for the future electromagnetic spectrum rationalization for healthy environmental ecosystem and the ongoing broadband regime intensification. The research provided insight into the 5G mobile spectrum estimation ranging from extreme low frequency, ultra low frequency, medium frequency, ultra high frequency, and extreme high frequency. The 5G electromagnetic spectrum compatibility evaluations were provided, focusing on the existent mobile technologies development below 20 GHz, where the environmental friendly 5G technologies will be established at present. The current research established that the radio frequency spectrum as synthetic national resources will become progressively competitive in the future for telecommunication business operations. The research concluded that the future telecommunication infrastructure development must diminish the influences of the electromagnetic frequency radiation for environmental health ecosystem sustainability. We move up. Then, looking at the methodology, the methodology that was adopted in this research, it said methodology involves studying most recent biomedical and scientific literatures that discuss the electromagnetic frequency radiation policy documents on the spectrum implementations and work on the International Commission on Non-Ionizing Radiation Protection 1998, 2010, and 2020 guidelines for the 100 kHz to 3,000 GHz frequency range. Research findings. The migration from the already existing 4G network to the 5G new radio broadband spectrum raises fundamental socioeconomic and environmental health concerns regarding the radio frequency electromagnetic field radiation from the carrier signal frequency antenna. According to the authors, the electromagnetic field EMF induces the circulation of electric current around the surrounding, coming from the low frequency non-ionizing radiation, and they can come from both natural and man-made technological synthesized sources like power line transmissions and telecommunication frequency-based stations. Naturally, the non-ionizing radiation is distributed into 4 sections according to their inherent electric energy quantum, such as optical radiation, microwave radiation, static electric magnetic field, and ultra-low frequency field radio frequency radiation. From figure 1, figure 1 is the electromagnetic frequency inducement of health hazard of deploying 5G network at ultra-high frequency greater than or equal to 220 gigahertz. Non-ionizable, non-visible radiation, electron-proton interacting as fields capable of adverse health effects, including heating up the human skin through polarizations and dipolar moment altercation, thereby destabilizing the equilibrium of the human DNA charged particles through the formation of free radicals that are highly radioactive due to the presence of the unpaired electrons that occurred when water molecules are broken. The formation of hydrogen peroxide compound from the free radicals will activate harmful chemical reactions within the cell, such as building up of fluid in the lung called pulmonary edema. Figure 2 is the chemical polarization effects, non-ionizable health hazard of deploying 5G networks at ultra-high frequency. This effect produces burns on the skin surface. It causes skin cancer, irritation of the body. So there are 3 spectrum use cases and application for 5G spectrum allocation identified as low band use case, the mid band use case, and the high band case. Then going to conclusion, the production of hydrogen peroxide compound from the free radicals will cause damaging chemical processes to occur inside of the cells, such as the accumulation of fluid in the lungs called pulmonary edema. Electronic health technology has a significant modification as a result of 5G network architectures for healthcare, which combine wireless fidelity with traditional 4G LTE network technology to increase the healthcare automation. This study came to the conclusion that if ecosystem sustainability and environmental health are to be possible, the future telecommunication infrastructure growth must reduce the effect of electromagnetic frequency radiation. The intentional deployment of 5G broadband system will necessitate enough and continuous electromagnetic spectrum resource for the development of novel technologies and enhancement of services according to the document currently under consideration. Now I'm going to question and answer section. So this is the end of the slides. And at this time we want to entertain questions. So no single person can answer more than 2 questions. So when you ask your question, you allow other people to ask their own. Thank you very much.